And at this point, we should all have an idea of how to factor. We spent weeks factoring quadratic expressions. That's what you were tested on Thursday of last week. Okay, so nothing has changed here. We're using the boxes. Okay, remember when we see factoring, we're thinking about how can we piece together two parts that multiply to get back to our original expression. With the quadratic, our main issue is that we only have three terms and we want four. We get the fourth term by finding two numbers that add to b, which in this case is 23, and multiply to a times c, which is negative 24. Those numbers are 24 and negative 1. So really I'm trying to factor 8x squared plus 24x minus x minus 3. The area model helps us do that. Once I have everything filled in, to find the outsides, again, we all kind of have different strategies of how we need to do that. I think it's easiest to think about multiplication. And so what times what gives me 8x squared? Well, there's actually a couple options here, but for this to all work out, I need to use an 8x and a 1x to get 8x squared, and 8x times 3 will give me that 24x. So I need to put the 8x on the same side so that it multiplies to give me the 24x. So that's plus 3, and then x times negative 1 is negative x. So this factors to be 8x minus 1, and then x plus 3. Now, the whole reason why we spent weeks factoring is because this is one of the main ways of how you solve a quadratic, right? So on Friday, you all solved equations or quadratic equations where you were able to use square roots, right? And that worked out whenever there wasn't a middle term or a b value, right? If I can isolate the x squared, we can solve with square roots. Well, if a quadratic has, thank you. If a quadratic has a b value or a middle term, we can't use square roots here, right? There's no way for me to get x squared by itself and equal to just a number. So factoring is another tool to help us solve quadratics. So this left side, this quadratic, is the same thing in our opener where we factored it to be 8x minus 1 times x plus 3, and that equals 0. Okay, so that's just me taking the quadratic equation and factoring it. After we factor, we solve by using what's called the zero product property. And you don't need to know this name, but we need to know what this property tells us. And so it means if we have A times B equal to 0, we need each factor to be equal to 0. So the zero product property says that if A equals 0, it doesn't matter what B is, right? 0 times whatever B is, it's still going to be 0. Okay, and same thing, if I took B and set it equal to 0, okay, it doesn't matter what A is. So what the zero product property is telling us is that for when we have two things that are being multiplied, we need one of them to equal 0, and then it doesn't matter what the other thing is, right? 0 times anything will always be just simply 0. So how that applies to what we just did is we take each factor now, so 8x minus 1, and I set that equal to 0. X plus 3, I'm going to set that equal to 0. And we have two equations we need to solve for. So the 8x minus 1 equal to 0, I'm going to add 1. And I get 8x equals 1. And then I'm going to divide by 8 to get to our solution of x equaling 1/8. Okay, then the x plus 3, if I minus 3 from both sides, I get x equals negative 3. So quadratic equations are going to have two solutions, right? With the square roots, those two solutions came from the plus or minus. When we factor, we're typically going to get two different solutions. So in this case, it's 1/8 and negative 3. Now I want to just explain the zero product property one step further now that we kind of have some values here. And I want to show you what the zero product property looks like with values, actually. So let's take this -3 and let's plug it back into the equation and see what happens. So if I plug in -3 back into the equation, I get 8 times -3 minus 1. And then that's times -3 plus 3, and it equals 0. Okay, at least we're thinking that. This is basically us checking our work at this point. Right, so 8 times -3, that's -24. And then that's minus 1. Then -3 plus 3, that's 0. And so this is -25 times 0, and it equals 0. Well, is that true? -25 times 0, is that 0? Heck yeah. Right, and that's what the zero product. All we need is one of these factors to be equal to 0, and it doesn't matter what the other factor ends up being when we have that value. Right, that -25 was irrelevant. We just needed to get to 0. The same thing would happen if we plugged in 1/8. We're going to get one of those factors to equal 0, but the other one's going to be just some number, and it doesn't matter what that number is equal to. So today's lesson is us factoring, and then just take each factor, set it equal to 0, and solve from there. Okay, so really just adding on to what we've learned about factoring. And here are steps written in words. Get the equation equal to 0, and be sure to write the quadratic equation in standard form first. Standard form meaning ax squared plus bx plus c. And we want it equal to 0. And we're going to factor the quadratic equation. Always look for a GCF. You're going to hear me say that anytime, we need a factor. Then set each factor equal to 0 and solve. All right, well, let's do one more together. And I'm going to have you all basically do the rest in your groups. I don't know if we need to do every one of these. Oh, you know what? I'm going to do 1 and 2, and then you all are going to do 3 and 4. All right, number 1. First step, get one side to be equal to 0. We are already there. Now we're into factoring. First thing I'm going to look for in factoring, is there a greatest common factor? Because if so, it makes the rest of this much easier. 36, 12, and 8, those all have a common factor of, what, 4? They're all divisible by 4. I'm going to divide out that 4 because it makes the factoring part much easier. So that's 4, and then this is 9x squared minus 3x minus 2, and it equals 0. Now I'm going to factor the quadratic part. The 4, or the GCF, does not go away. Okay, and we'll talk about how that might affect our solutions once we're done with the factoring part here. So now I need to find two numbers that add to -3, multiply to -18. Those numbers are -6 and 3. And so really, we're factoring 9x squared, and then -6x, 3x, and minus 2. I want to think about how can I get this 9x squared? Well, I can do 9x times 1x, but no matter where I place that 9x, I can't multiply it to get to the -6 or to 3. So the other way to get 9x squared is with 3x and 3x. So 3x times 3x gives me 9x squared. 3x times -2 is -6x. And 3x times +1 is 3x. And 1 times -2 is -2. So we've taken this original equation and we factored it to be 4 times these two factors we just found. So 3x plus 1 and 3x minus 2. And it's all equal to 0. Now that we have factored, we take each factored expression and set it equal to 0, and we solve individually. So this is where we got to think about, okay, the greatest common factor, are we getting any sort of solution from that? If I set 4 equal to 0, is there anything for me to solve for there? No, we need a variable, right? 4 equals 0, that's a false statement. Okay, so in this case, the greatest common factor does not change our solutions. Okay, so even if you didn't take out the GCF, that is okay. You're going to get the exact same answers. There will be times where that greatest common factor gives us a different solution. We're going to see that in the next example, actually. Now I'm going to take 3x plus 1, set it equal to 0, and 3x minus 2 and set it equal to 0. So I need to subtract 1. So I get 3x equals negative 1. Then divide by 3. And I get x equals negative 1/3. Three x minus 2, I'm going to add 2. So I get 3x equals 2. And then divide by 3. And the x equals 2/3. So our answers here are negative 1/3 and 2/3. All right. Any questions here? With the 4? Yeah, so, and that's what I was kind of trying to show us on the side here. By me taking out that GCF of 4, it's not changing my solutions because it's still a factor. There are technically 3 factors here, the 4, the 3x plus 1, and the 3x minus 2. The 4, it doesn't have a variable, so there's nothing to solve for there. So that 4 actually does nothing in terms of what our solutions need to be. Okay, if you did not factor out the 4 and instead it was multiplied into one of your other factors, you're going to still end with the solution of negative 1/3 and 2/3. Okay, so Ty, in this case, that 4, we can basically ignore it. Okay, that's not going to always be the case with GCFs, but in this case, we can because it's just a number. Now, that's actually simple because number 2, what's the GCF here? 2 and what else? What do they all have? They all have an x. Okay, so in this case, the greatest common factor of x is much more important than the 2. The 2 is like a bonus. Okay, it's the x that's really important here. Because it's the x that's going to allow us to then get a quadratic that we can then factor from there. Yeah, it's right here. All right, so let's divide out this 2x. So 0 equals 2x. And then that's x squared plus 2x minus 3. This needs to get factored next. And then we'll set each factor to equal to 0 and solve from there. Why don't you all take a minute and try it yourselves. The very minimum, factor x squared plus 2x minus 3. Then take each factor set equal to 0 and see what solutions we come up with. Okay, let's look at the factoring first, and then I'll talk about the solutions here because our GCF gives us another solution in this case. So the factoring, I'm looking for 2 numbers that add to 2 and multiply to negative 3. Those numbers are 3 and negative 1. And thus we're really factoring x squared plus 3x minus 1x minus 3. And that factors to be x plus 3 and x minus 1. So in total, this original polynomial, okay, or cubic function, factors to be 2x times x minus 1 times x plus 3. When I then take each of those factors and set them equal to 0, the GCF means something now because now it has a variable, right? We have that x there, so there's something for me to solve for. So with 2x equaling 0, I get a solution that is 0. With x minus 1 equal to 0, I get a solution of 1. And then with x plus 3 equal to 0, I get a solution of negative 3. Okay, so when the GCF is a variable, you will always have a solution from that, as opposed to the GCF being a number it won't change what our solutions actually end up being. Okay, it's only when it's a variable there. Okay, so here's what I want to do. For the last two, I just want to get us started, and I'm going to have you finish those two on your own. But I do want us to work through these last two because we get some little bit different way with how these work out. All right, number 3. First thing, we need to make sure one side is equal to 0. We've got that. Then our task is to factor this. And first step in factoring is always find a GCF. In this case, the most important part of the GCF is the variable and not the number. We want to factor out the variables so that we get something that is a quadratic term left over. So all of these terms have an x cubed that I can factor out. In addition to the x cubed, they all are also divisible by 3. So I'm going to take out a 3x cubed, making this equation 0 equals 3x cubed. And then the quadratic that will need to continue to be factored is x squared plus 8x plus 15. All right, on number 4, because I want you all to take number 3 from there and finish it on your own. Number 4, nothing is ready for us to solve yet. You need to get one side equal to 0 before we can start to factor it. So with number 4, we're going to start by adding 2 and minusing 2x from both sides. So minus 2x, and I'm going to add 2 from both sides. That makes this right side 0. That makes the left side 4x squared minus 14x plus 6. And I want you all to take it from there. Okay, this needs to be factored. You factor it and see what the solutions end up being. We'll say about 5 minutes to try to solve or factor and solve the remaining 2 problems here. I'll come around with homework shortly after. Do your very best, please. And I actually left a couple things unfinished so we can kind of chat about them as they show up here. So I got us started by taking out the GCF of 3x cubed. X squared plus 8x plus 15 should factor to be x plus 5 times x plus 3. The x plus 5 and the x plus 3 gives us solutions of negative 5 and negative 3. The other factor here is that GCF of 3x cubed. Now, a lot of us, we're going to get to this point and be like, I don't know how to solve that. We haven't solved anything to the exponent of 3, care to the power of 3. Well, when we have a GCF that is just an x and it doesn't matter what the exponent is, we're always going to get a solution of 0. But here's why. Now, if I try to get the x by itself, I would start by dividing both sides by 3. So dividing 0 by 3 is just 0. So I get x cubed equals 0. And then to undo cubing of something, kind of like to undo squaring something, we take the square root. We would take the cube root. And the cube root of 0 is actually just 0. So cube root, x equals 0. So we get solutions of 0, negative 5, and negative 3. All right, number 4. If one side is not 0, that's our starting point. We always need one side to be 0. So I add the 2 minus 2x. Then on this left side, there's a GCF of 2, but I'm pretending like I didn't notice that, okay, which will happen to some of you, and that's okay. Okay, there's nothing wrong with it. The only time we have to factor out the GCF is if it's a variable. Okay, if it's a number, it's just a bonus. Okay, and this will kind of show us why. So I pretend I don't notice the GCF. I factor anyways. I factor to be 4x minus 2 and x minus 3. Well, I can still solve those, right? 4x minus 2 gives me an answer of 2/4. X minus 3 gives me an answer of 3. Well, if there was a GCF, we can see that in this 4x minus 2, right? This factor has a GCF of 2. So if I were to take out that GCF of 2 and get 2x minus 1, well, 2x minus 1, when I go ahead and set that equal to 0, I get 2x equals 1 and x equals 1/2. What's the difference between 1/2 and 2/4? Is there any difference between them? Not one bit. Okay, those are the exact same values. Okay, so my whole point here is that when the GCF is a number, it doesn't change what your solutions end up being. So if you forget that part, you're okay. Still want it to be a habit to look for those greatest common factors because it does make the rest of the work much easier.